First of all, this is the session. It's kind of the continuation of the session we had a couple of weeks back. And then in the first session, I mean, in the session that I covered the previous week and last week to the last week, we went over the LangGraph foundations. And then I just introduced the concepts behind the LangGraph and then a few things around the components behind the LangGraph. And then we did not have time to go through the code and then go in detail. So in this session, I'm going to go a little bit more deeper and then show you the code base where how to build the multi-agent using the LangGraph. And then as part of that, I'll show you some of the existing pre-built agents that is available as part of the LangGraph. And then I will walk through the pros and cons of building the agents all from scratch versus something we can use pre-built agents. And then, important point, part of this today's session or presentation is to actually show very interesting aspect of evaluation. So a lot of these multi-agents, if you are coming from the RAG background, you probably heard about evaluating RAG responses and then applying the guardrails and then understanding the accuracy, correctness, and then faithfulness, all kind of evaluation you might have heard about in the RAG. But in the agent scenario, it's a little bit more, adding to that, more complex. Because in the case of multi-agents, in addition to those evaluation responses you may be familiar in the RAG, during the RAG building, in the agent scenario, there are more complex things, how the agents are communicating. Are they communicating properly? Are they communicating as the expectation we have? A lot of these things are, I would say, complicating the testing portion of the multi-agents. So any successful agents, AI agents project would need to have a very strong foundation about evaluation and then testing and then how to monitor offline, online. I'm going to cover those kind of things as part of today's presentation. So at the end we will go through some best practices and there are a few interesting points folks are observing in terms of agents. Where does it break? Yes, it does sound like it's working in POC scenario, but in practically when you implement, where does agents workflow go wrong, and then how to work around that. So I will cover a little bit on that best practices. So that's the agenda for today. To start with, let's quickly review the little bit foundation. So we are going to start with a little bit of preview, and then we'll go deeper quickly into the example walkthrough. So just a review in case if you're joining first time, some of you joined for the first time. Again, we covered a lot of this foundation 2 weeks back. But when you're, quick review is when you're building an agentic system, what we are really talking about is building the agentic workflow. Yes, you can build in a simple one agent. Yes, that's it does solve some problems, but real complex problems are solved by multi-agents, agents with a lot of what I call steps. You can imagine, if you're coming from enterprise, you do have a lot of workflows, business workflow, business process. These are all having a lot of steps. Similarly, in agentic workflow, you would have a lot of steps, and then that's all part of the workflow steps to finish or execute some business process. And then there is an aspect of multiple agents, each agent specializing in some unique roles and responsibility. So these two things are going to be the key foundation for building the agentic workflow. To make it simple, there are two categories of workflow. One is a predetermined workflow. Here in the diagram you see predetermined control flow. Sometimes it's called chain. And then other one is what we call agentic workflow. So we are going to quickly talk about pros and cons, dive into the example. So in the predetermined control flow, what you have is your code actually, you codify, you apply your human programmers, developers, codify that workflow. As you see, there are many types of that predetermined control flow. One is simple steps, the first one. As the more one, even the last one, which is, you see that starting, right? And then it does branch out to the step three. Step one, after the step one, some kind of checking might happen, then it takes to the step three. So if you have those steps controlled using if then else statement, then it's a, we can call it as a predefined or predetermined control flow. So this is one aspect of, yes, you can build agents. Within agents you can have steps which can be done through the predetermined control flow. So this is, I would say, a simple aspect of the agentic workflow. So what is the other one? Other one is more of the what we call, we covered as a React agent pattern, in which the steps inside the agentic workflow is more stochastic or more reasoning coming from the LLM, not the coding that we do if then else. So here the LLM or LLM based reasoning will try to, based on the prompt that you enter, we are going to see in the example, prompt you enter, it's going to basically reason through the steps, what steps to execute by the by the using the tool calling. The standard word tool calling is an important keyword. So using the tool calling support from LLM, it's able to decide which tool to call and then make some decisions to continue until the end. So this is called another pattern in the agentic workflow. So now this is not predetermined control flow. We are basically the LLM reasoning engine decides the control. So these are the two different classes of, I would say, categories of a agentic workflow development. So the key point now we need to realize, the controlled flow, predetermined flow, is not flexible but more reliable. Of course, the reason it's not flexible because you basically predetermine the control, right? You cannot go and change runtime. That's why it's not flexible, but it's of course more reliable. So you can imagine a lot of our business process today, of course, it is not LLM based, but it's based on steps, is more reliable but less flexible. On the other hand, the React based pattern that we've been exposing is very flexible but less reliable. I mean, more than flexible, I would say it is making the decisions, reasoning decisions using the LLMs. Okay, and then flexible could be that you can change the prompt a little bit, or it could be that model can be fine tuned. All those things is part of the flexibility. So that's aspect of two different aspect of building the AI workflow. So with that said, let's go to the LangGraph example. So what we did today, we are going to cover. So what we are going to do, we are going to go through the multi-agent example. So what is the example I'm going to go through? So, as I'm talking, you might, if you have time, you can also set it up. So this is the page, it's provided by the LangGraph. I'm going to cut and paste that, or you can see that. Now, this is a page. If you have time, you can install as we talk. It has a wonderful example. This is, I think, one of the training in the LangGraph in the academy, actually covering this little bit, but actually, but not in full detail. But today, we are going to walk through that. So when you get time, you can install it. But right now, you can also go through with me on the steps. So what we are going to go through is a multi-agent notebook. So in my opinion, though there are a lot of examples you can see in the LangGraph, this is like a superset of all concepts covered. I mean, if you can walk through and get the points from this workflow, pretty much it covered all the capabilities and features, knobs, etc. that LangGraph is offering today. So that is the thing we are going to go through today, right? So what this example in summary is, it's a music catalog. Imagine, this example assumes there is a music store company which sells some musics, right? And then, of course, part of that, it has a catalog, and then it will have a few customers and then invoices. All those things are behind this simple example. What we are going to build is a notebook or application which going to be chatting with the agents and then showing you the answer. That's the idea behind this notebook. So let me also talk about a little bit about the. So let's go over that again. So when you want to build such application, right? So you can build any application in many different ways. So in this case, this music, what we call catalog and support application, we can build it using many techniques. You can build it using RAG technique, but it has some limitations. You can use RAG plus tools approach. You can also have MCP tools. In this notebook, I'm not using, or this notebook is not using MCP, but you can imagine you can use MCP. So we are going to be following agentic workflow using tools as the architecture approach for this tool. And then as you see that, you can further keep improving or enhancing this workflow. You can implement the MCP tool as part of the agentic workflow. You can also introduce something called text to SQL, deriving a lot of this extraction using automatically. So you can keep improving this workflow or this notebook. Okay, so just to get you in a feel of what this application is going to do, we are going to, there is a Chinook database. This is seems like this is a very popular database used for many different examples throughout the, in the tech career, right? So it uses examples and it has 11 tables and then 15,000 rows of data. What this contains is pretty much like, as you see here, it contains a sample artist, albums, tracks, all the media types, playlist, and then of course customers and the invoices. So you can go through this actual data on your time, but for our walkthrough, we don't need to go into the data set. So, but you get an idea about the schema here. So now what is the purpose of the schema? Why we are talking about here? Yeah, we are trying to build we are not trying to build a RAG application here. Though this notebook, or we can extend to process unstructured documents, but in this simplest example, we are going to use what we call LLM and React based agents, and then we create multiple agents and multi agents and use tools as the way to get information from this database. So that is the idea behind the notebook. So it is going to the focus of the notebook is to demonstrate the LangGraph features. In reality, in real projects, you can take up this project and you can apply to your company or any situation you have. Most of our enterprises have databases, right? And then you can imagine database is one source for the agents, which is this example is going to show. And then other cases, you can also have a tool which does the RAG kind of a thing, process the unstructured documents in the vector DB. And then agents can combine that information. But here in today's, it's going to be simple database-based information extraction. So here is what, a little bit questions this code walkthrough is going to answer. In this example schema, you see three different personas. One is the customer persona. When you have the chat bot, customer is going to ask what they have purchased and stuff like that, history and billing. And then other one is salesperson, right? I mean, there may be a sales persona. They were trying to understand the customers' pain points or customer segments, insights and stuff like that. Other one is a sales insights manager or management. So here they want to look at reports and then agents performance. Agents means here it's a sales agent. That's what it means. And then things like that. So that, we will stay at high level because we are not going to go in each question to answer. Rather, our focus is more of technology. But these are the kind of questions. What I want to point out here though is you would see, what's a big deal about simple questions, right? In the past, simple SQL statements is going to be getting these answers anyway from the database. What is the big deal about the agents? I think what you're going to see that as you encounter more complex questions, then agents working together, and then until some criteria met, it's going to be in the loop to answer complex questions. That's where the real benefit is going to come, not like simple question answer. So in other words, it has to do multi-step reasoning, right? I mean, that is of course, the multi-step reasoning means which is usually, imagine you are an analyst, and then you have this database, but you go to reports, several reports, and then correlate some information, and then finally you derive some kind of insight. So here, we are expecting agents to do that. So the real benefit here is, if the agents that we are developing can do this multi-step reasoning, and then of course this is something new. So the whole idea is, we are going to enable the agents to do the multi-step reasoning. So that is a very key aspect. So if you apply that to your problem, you would imagine, you can easily see so many insights from the regular enterprise database now can be made it work through agents. That's a pitch of AI agents. Okay, so with that said, this is what the agent we are going to build. So what we are saying is, this is what we want to build. This is the architecture we want to build, and using the LangGraph. And then as part of that, not only build, we also need to evaluate. And then, as I was saying, the critical piece is, how do we know that agents are working, right? That is a hard part of it's like testing the agents working properly or not. So now, LangGraph is as it sounds, as it says, it's a graph architecture, right? We are going to model the agents and then steps behind agents as a graph. Why LangGraph went with graph, unlike Crew AI? In Crew AI, there is no foundation concept of graph. Crew AI, for example, has roles and tasks, and then roles and responsibilities, and then it does have something called sequence to connect the flow, but there is no concept of graph. But LangGraph really starts from foundation, right? This is how you can visualize. There are many types of agentic builders are there. One is the UI, very high agent force, which is from Salesforce. You can easily build agents for the Salesforce data, as well as nowadays for external data as well. And then similar to that, NI10, it is something enterprise can use, which has a UI based workflow definition like Camunda and other BPA processes. So those are all at the very high level. And the next level is something like Crew AI AutoGen, where you can go and you don't need to know a lot about how agents communicate each other, and that is taken care of by the platform, but you kind of specify the roles and responsibility of the agent. And then the third kind of a thing is what LangGraph. It provides a next level where you can go and define the control flow and then nodes. You can stitch together. So the benefit is, some companies like this approach because it gives full control and then full visibility, right? Compared to Crew A and then AutoGen. So as you are going to see, we are going to build a quick graph behind that. So I'm going to switch to, anyway, I'll take a little bit more time, and then I'll switch to the notebook. So what you want to notice, right, when now that we know the concept, but what we really need to notice as we develop is, these agents are going to be communicating to the LLM, right? And then making some decisions. So as a developer, we need to, as we develop, also during the, development time, maybe a troubleshooting time, we need to be familiar with, what kind of exchange message is happening between your LLM and so your agent code, and then to the LLM. So that is a very key aspect of developing a good agentic software. So here in this example, you would see that the system message, and then you would see AA message, and then something called human message. Right now it's missing. Yeah, the top one is the human message. The tag is missing. So the human message is what you type in the prompt, or the feedback from the user. And then AA message is basically the one that the LLM, the reasoning engine or LLM gives back. So in this case, it is a tool call message, right? So maybe at this point you're familiar with LLM has two broadly, even more type of messages. One is a tool calling message. One is a regular message, right? So the tool calling is a feature of the LLM where it will tell you, what tool to be called, right? In the by the client. So that's a foundational aspect of, rather later it became MCP in a big way. But before MCP, tool calling was the approach to call your enterprise data through some, tools and then pass it to the LLM. So tracking these messages, as the agents working through is a key aspect. So how do we do that? That's where LangGraph, LangChain company provides two other components. One, I'm going to cover platform, LangGraph platform, and then LangSmith. So these two, one is what you're developing, what you're developing using the LangGraph library. And of course, you can execute that LangGraph in your laptop. But in reality, you also need to have a good tracing, how the agents are communicating. So that's where the LangSmith is going to come in handy. So I will show you that LangSmith also as part of the demo. So we are going to go a little bit detail, but all I want to point it out, as part of the developer, we need to be very familiar with these messages or understanding these messages going on. So let's look at that. Let's go to the approach, right? So what we are going to do before we jump into the notebook, right now, first thing we need to do is get the data set. What data set? Chai Nook database data set, right, into the notebook. What in this example we are going to use SQLite, that's an in-memory database. So all those 15,000 or 14,000 records and schemas will be loaded into the memory in a SQLite memory, which is inside the notebook. Yeah, it's not a big deal, if you have a MacBook with 16 GB memory, it's not very big database. It's very small. And then once we download that into the notebook, first thing is we are going to develop it's a multi-agent we are trying to develop. So as a developer, we decided that we are going to have two different agents. Music catalog agent, which is role and responsibility is to provide answer any questions related to the catalog, given the song, who is the artist, given the artist, who are the what are the songs. So anything related to the catalog, it will be answered by the music catalog agent. It could be a simple question, it could be a multi-step question. So so the music catalog agent would need to answer a very complex question, not like very simple questions. But anything about the catalog, you should able to answer multiple criteria, multiple conditions in the prompt. Then music catalog agent it's a React based agent, so it should be able to go in a loop until it gets the answer. I mean, when you look at the code looks very simple, but apparently it's doing that in a multi-step also very nicely. Similarly, invoice agent is responsible for only answering about customer purchase, invoice number, amount behind the invoice. Again, here you should be able to answer any complex question. I mean, the agent should be able to answer any complex question. And then you do have multi-agent. You build over that, add more extra complexity, right? There are some prompts which may need to figure out the good catalog and then answer this song is purchased already, for example, right? For that, it needs to first get some information from the catalog, and then it gets to go to invoice agent and then get the answer. So the multi-agent organization needs to answer higher level reasoning questions. So that we will develop as part of the step 4. And then we will add some input validation, like any chatbot will validate the input, we'll do that. And then part of that is, a key concept behind the agents are about memory, right? Long-term memory and short-term memory. And then there are concepts we introduced a little bit last time called snapshot. So those things I will again talk about as I walk through the notebook. So in the right-hand side, I have steps, right? First step is to download. So it's a pretty obvious one. Basically what we are doing is in the notebook, we are initializing the engine, and then we are getting the DB. So, this is a standard SQL initialization call. And then this piece of code is going to the HTML URL from this page, and then get that text SQL script. SQL script will contain all the insert and update and all kind of things. And then it's execute the SQL script. So by this time, you can imagine there is a SQL-like database running inside the notebook, right, with this interface. Okay, that's pretty straightforward. So next is developing the music catalog agent. Okay, here, yeah. So this is one of the agent we are going to develop. All right. So in the last week, I went through some patterns, right? I mean, there are few patterns of agents, reflection agent, React agent, and then workflow agent, things like that we went through. But React agent is the most popular, and then agents, right? So here, agentic framework or agentic pattern. So the notation looks like this. In the graph, we're going to model that React agent as a graph. So the graph will have a starting node connected to the music catalog sub-agent node. So now we are going to, say something, use the word called node. So node, you can correlate to steps, but it is more than that, because steps does not convey that there is a state inside that, but node conveys that there is an aspect of state. A node can maintain a state, and then it can also execute some logic. So node contains a state and then logic. So this node contains a state and then logic to find any information about about the music and catalog. And how does it find? And it's going to be working with music tools node. In the music tools node, there will be a bunch of tools. In this example, it's a simple tool, but you can expand. Imagine these tools can be an MCP, client, which can connect to the MCP servers. But we are not going there right now. But here we are simply saying music catalog node is going to be working with music tools node in a loop form until it answers the question. So it sounds simple. But another way to see the little bit in detail, actually this will get displayed when you in the LangGraph, after you build the graph, when you say show me the graph, it's going to show this diagram. So here, a little bit, what is the extra detail here is, it shows something called conditional branch. This is a key aspect of the LangGraph. We did cover in the last meeting. So we are going to codify how to do this continue, right, until the node is in. So this is a very basic concept of React agent. Again, for the folks who are joining the first time, this may be this is the piece we need to understand for agents to work and reason by itself. But we'll go through the code. Okay, first thing is about a state. I'm going to go, obviously in the code, when I walk through the code quickly, I'll show the env file and stuff like that. And here is the model that we are connecting it, right? In this case, O3 mini. But the important part of the slide here is a state object that is maintained by the LangGraph and then passed on to each node. So that's a key thing. So you have to visualize in a graph has nodes, and then there is a graph execution engine. That's a LangGraph engine. Will be running these nodes, to start with, think it as it runs the nodes one by one. But in reality, a little bit more complex. It can run the nodes in parallel. It will figure out when to run the nodes in parallel, when to not to run parallel, wait for the node to get complete. It's all based on the graph theory, right? Cyclic graph. So the LangGraph takes care of all those things. But as far as we are concerned, we just need to visualize the state object is passed on to the each node. That's one thing. So that means it's a shared object. it will have customer ID, right? In this example, messages. Messages means what are the messages coming from the human as well as from the LLM. It keeps track of those messages, the LLM messages. In the RAG world, we do it in the history and stuff like that, context history. But in the agent world, imagine every node um, will have a state. In the state, you have all the historical messages. And the loaded memory, this is something what we call long-term memory. So the idea behind LangGraph is you maintain anything about about that customer profile or customers last 1 year summary of purchases or returns, which is available in the database. But sometimes, right, I mean, you can keep the summary of conversation of customers also as a long-term memory in addition to the profile. So you keep it in a loaded memory. It could be a key value pair, but in this example, simple string. And the remaining steps is another interesting placeholder, because the React agents goes in a loop called agentic loop. Imagine you ask a question, right? And this agent, with the help of LLM tool calling reasoning, it is going to be going until the loop the question is answered. So suppose the question is not answered, right? If it goes in a loop, you want to come out after a certain time. So the remaining steps is a technique to note down, after 5 steps, the agent say, I'm not able to find out. You can use for that. Okay, so where are we now? So we are simply set state, right? I mean, state is the important part. If you look at here, we are still in the music catalog agent, right? I mean, we have a long way to go. And then, but the next step is the tools, right? We are going to define this agent and then tools. Let's first define the. So we have first we'll talk about the tools, then we'll go to the agent definition. Okay, now tools are very simple. In the notebook you will see the code, but here I'm going to stay at this level. There will be 4 tools: get albums, tracks, and songs. Right? You can keep adding tools. But this is where this is just an example. In the real enterprise network setup, these tools also could be using text to SQL. It can be more dynamic, but in this notebook it is very static example. Okay, we are going to develop the tools, and then now that this is a key thing. Now we are still defining the node, music catalog agent node. So music catalog agent node is a LLM based reasoning node, right? It does not have any logic coded, right? That's a foundational aspect of AI agents. There is no code. And the code is maybe related to getting some information from the memory, but the real logic is a prompt. So this is a prompt which is defined in music agents. You can go read slowly, but as you see that you are defining what's the responsibility of the music catalog agent. For example, search and provide accurate information about the songs, right? And then help customer discover any new music. So writing is this is a prompt is the what we call new code, right? And then yes, how did we develop this prompt? Right? We are looking at the end product, where in this notebook they developed the prompt, but it's obviously a not easy task when we need to develop from scratch for our application. So it sounds simple, but in reality you cannot come up with this prompt as a first time, right? You don't know whether it covered all the use cases, all the scenarios. So that is where the concept of iterative development, and then looking at the evaluation, and then whether it's solving all the questions or typical questions we are doing. So it's more and more important to be more proficient in the other part, LLM ops. I won't call LLM ops, but defining the test cases, evaluation cases. In fact, the real mature organization starts with that first, and then come to the prompt in a second. It's not the other way. It's not that we write the prompt and then test it and then change the prompt. It's going to be the other way. We will have some empty prompt or default prompt here, but we are going to define evaluation first. I'm going to cover that. So for now, imagine this is the most complex sort of the developer's brain going to decide this prompt. Okay, so you define this prompt. At this point, based on our best effort, we define this. Okay, then we need to put together the graph. Remember, we just created the node. We just defined the node, but we haven't created the graph yet. So there are a bunch of few statements to do that. Okay, so this is pretty simple, right? You define the state. Again, this is the same mechanism all over. Everywhere you'll see in the examples of LangGraph. You create a state, and then you add a node called Music Assistant. You add a node called Music Tool. These are the Music Assistant is the one we defined here. If you look at here, all right, and then that node, if you go a little bit detail, all it does is it gets this prompt. You can as well as have a prompt here, and then he has a logic. You remember I told every node has a state coming into the node and also have a logic. This is a logic. So logic here is a prompt sent to the LLM along with the messages. Now, if you look at these messages, this is the messages of conversation between the human and the AI. So as time proceeds, in this, when you type the state messages, it contains all the conversation between the AI and human. So we just pass along that, right, and to the LLM, and then we get the response. Now, I mean, now it's simple. This part is simple, but still it's not full story yet. The reason is we haven't defined any conditional loop yet. It's just isolated right now. So we are going to do that. We are going to finish the graph, right? And then what we do is we then basically, this is a, every graph has a start node in LangGraph. So you create the start node and then attach the Music Assistant, right? And similarly, now we have to attach the end, right? But end is a conditional, right? Start is pretty simple. But end of the graph, because every graph, if you think from LangGraph graph engine execution perspective, it will need to reach the end. For a given human input, it has to reach, the goal is the flow has to reach the end. So here, but you're making some conditional. This is a key aspect of the React agent. So this one, you have to take time to get it. Last week we went in detail, but what we say is, in some condition, this conditional criteria will decide to continue to be in the loop or to end the loop. Then there is a should continue function. The should continue function, I think this is a very, very, very important. Should continue function basically look at the LLM messages, right? Imagine we are calling the LLM in the loop, and the LLM is going to come back and say, yes, call this tool, and then it'll, in the next time is going to say, yes, call this tool. And then if you remember the flow, we call the tool, we get the response from the tool. We're going to attach that in the, LLM messages. And then we are going to call the LLM. The LLM look at all your original question and then answers so far coming from the tool. And then it decides at some point, yes, looks like everything is answered. So we are not deciding. LLM then decides, the reasoning engine decides end. Then it returns the word end, saying that, we are completed or we have concluded it. As far as LLM is concerned, I'm able to see that your question is answered. So it will send some signal called end. So it won't send the end, but it will have an indication. Either the response is a tool continuation of loop tool response, or LLM thinks, yeah, this is answered. This is my answer. What we do is, if the LLM is not saying any more tools to be called, we infer that we are reaching the end of the tool calling loop. And then on the other hand, if LLM says call this tool, we are going to say continue. So this is a piece, it's going to enable our continue versus end, right? So this has to be instrumented and tested properly. Again, while we are coding it, we don't have any visibility, right? Whether LLM is going to say tools, or done, or good. So there is no visibility for us when we develop. Again, only way to have control over this is look at, you need a tool like Langsmith to look at the responses coming from LLM. Okay, so the story is, the message is, it sounds simple, right? In the new world of coding, there are few aspects are simple. The instrumentation is simple, I would say, not much coding. And then if you have agent builders, nowadays every company, everyone is creating an agent builder, right? Agent builder, at the end of the day, right, is as if you can able to create a prompt, and that is a main, I think, IP behind any agent builder. The intellectual capital behind agent builder is to create this prompt. If it can create, it can easily create these nodes. There is no, it's not a big deal. It's just a template code, which can, from UI, you have a fancy UI which can assemble this code, translate or generate this code pretty simply. So nowadays, building the agent builder is not a big deal. It's just a couple of days work. But prompt engineering, here is a basic. How you derive the prompt is a crucial factor. So now with that agent builder, though we are not talking agent builder, you can imagine that you can create this graph pretty simply. Okay, we are done with the agent filler. So now we are going to go back. Now this is the time we'll go back and execute in the notebook. Let's go back to the notebook. And then we'll pause for a while. So I have two things in the notebook. I hope it is going to work now. In the left-hand side, I'm going to click on the multi-agent. Okay, so what we are going to do is I'm going to show the Langs, I think that one of the learning from this today's session is to execute this and see the action, right? The trace the messages in the Langsmith. So that is a typical development. Okay, I'm going to already set up, right? Here, if you look at my notebook, it's already set up. I'm going to a little bit, I'm going to one by one. In the top, the VNV is selected. So I'm going to clear all outputs, and then I'm going to restart the notebook. I'm assuming I have all the connections. And then I'm not going through the .env. I don't want to show the details begin .env, but you can imagine all kind of connections are there. Langsmith URL, as well as the OpenAI keys embedded in the .env example. I don't know what is in .env example. Yeah, okay. So this is I'm just showing the .env. Here you can see these are the keys. It is an example. I didn't have the actual one. The .env has the actual one. Okay, but these are the keys. So what are we trying to do? We are trying to create the first agent, which is the music catalog agent, right? And then first is read from env, and then we are going to connect to the OpenAI, right? And then we are going to load the customer data. So at this point, it's loaded the customer data. You can see the tick mark. And then, yes, yeah. So this is, we haven't talked about that, but I'm going to imagine that there is a long-term memory and short-term memory. So the long-term memory, right now we are using what we call in-memory store. I mean, the notebook is using the in-memory as a long-term, um, but LangGraph or LangChain provides integration to SQL and MongoDB. There are many, like in memory store, you will have SQL store, MongoDB store, things like that is provided by MongoDB. So for that, when you use that, you need to initialize with proper parameters, I guess. So, but this is a long-term memory. And then there is an aspect of thread level memory. This is another concept. It is I won't call it as a short-term memory. The check pointer is an important concept. In the node, if you think graph consists of multiple nodes, and then there is a graph engine, execution engine, goes through its nodes. Sometimes, multiple times it will go through it. First time it goes through the node, music catalog node, and then engine control goes to the tools node and comes back to the music catalog node. So it goes in multiple steps, right? So the graph engine, LangGraph engine, maintains, remembers a state, because every node has a state. Every node can be revisited n number of times. Every time, for the purpose of many reasons, right? The LangGraph automatically saves the state information in checkpoints. So that is the power of the LangGraph. The power of the LangGraph, it maintains a checkpoint. I'm sure there may be some limit. It may have 10 checkpoints for each node or 20 checkpoints. I don't know what that limit is, but it's able to maintain the checkpoint, wherein in some cases you can fall back, revert back, look at the previous instance of the state, timestamp. So all those things they provide. How we use it for our implementation is up to us. How our agent is handling the failures, and then recoveries, things like that. They allow this foundational things to us to implement. To utilize. So okay, that's about the checkpoint. So now I'm just going to quickly build this music catalog. So in the left hand side, if you look at how I already ran many times, but as we running through that, you'll come to know music catalog agent will be run, and then it will be the traces will be there. So I'm going to just continue here. State, we went through that, right? As I said, state has a customer ID, conversation history, memory from the long-term store, remaining steps, right? So I'm just continuing that. We have seen this. Yeah, this is a tool I told, though in the PowerPoint, I didn't see the code. I didn't have the code, but you can see that it has these tools defined. So it's going to get albums for the artist, get tracks by the artist. So you pass the album name, it's going to query the albums. You pass the artist names. Here it's going to get the tracks created by the artist. So these are all the standard SQL commands. And then we are defining nodes, right? This is what we went through. This is the actual prompt to tell the node, music node, to work with LLM. And then here is a conditional edge we talked about, right? And then we had to compile the graph. We saw the snippets in the PowerPoint, and then we're just executing it. Right now, what we are doing is we are just at this point. What happened is a graph is created, right? And then it is actually not executed at this point. The graph is compiled. You can say that, and then graph is as of now sitting in the notebook, right, in my laptop. But while testing, it's going to be communicating to the Langsmith platform. But at this point, the graph is ready for execution. Our agent is ready for the execution. You can consider that way. So by the way, just because I'm showing this notebook, it doesn't mean it's not an agent. It's actually an agent, but it's running in the notebook now. Now you can take this agent and you can deploy in the platform, LangGraph platform, and then thousands and thousands of users can run it. So that is the aspect of the LangGraph platform. Okay. So now I'm going to now run it. I'm going to test it now. So here is what we are going to test it. Okay. So this is where I was telling we need to be, as a developer, we need to be knowing, how actually the flow happens. So in this case, question that human is asking this, right? I like the Rolling Stones, and what songs do you recommend them, or by the other artists I might like? So this is a lot of interesting thing, right? I don't even know how it's at this point. that I might like, right? As we are running through that, we don't have anything in the long-term memory. But if I know for this user songs I like, that will go into the context. So idea is, as you build complex application, this is to illustrate that some profile is stored in the long-term memory. So right now I'm just calling that. So now the agent is called, and then execution is happening. So behind the scene, a lot of things are happening. And if you look at the final answer, here are some top Rolling Stones tracks you might enjoy, right? So, this is the answer from LLM, right? But we are more interested in what is the flow, right? So when you type the human messages, it's going to call the AI first. Then AI going to decide to answer this to answer the question that the user entered. I need to be calling the get tracks by artist. Then the agent code, our LangGraph platform, is going to be calling the tool. It's a React agent. Remember, we put together a React agent, this agent that we created, right? This is what we call music catalog sub agent. So that we created. Now we'll be calling the get tracks by artist, and then you get some data, and then again it's going to call the AA, saying that AA will then get back these messages. So this is a sequence of steps happening, workflow happening. This is very simple. In this example, it called the tool only one time, but that is to illustrate some simple example. But in real work life, in a workflow, you can see that you would see multiple times the tools are called in a complex reasoning steps. These tools will be called multiple times, and then multiple times the AA message, AA will be called until you get to the end. So but that's where the we believe the AI is taking over, right? In complex steps it can take over. Okay, so now look at the line, back to here in the Langsmith. So what you see here is music catalog sub agent, right? So whatever you saw in the output from the notebook is actually more, you would see more such tracking in the Langsmith. So this is a power of the embed. We don't need to do any coding to enable the tracing. All we did was point to the tracing server. So I'm going to pause after that, and then I'll wait for some response. But here, you see here, right? I mean, the simple music catalog has multiple steps. If you look at here first, the human input, you can collapse this and see that, and then you can see the whole thing. But there are some interesting. It will show how much time it took and stuff like that. Okay, so you can go. You can see the sequence. First is the music assistant node. It calls the LLM node, and then LLM node responds by saying that should continue. Remember the should continue function that that is based on the tool calling response from LLM. You can see that. So you can see that each of those steps tracked by here, and in the top you can click as a one time and see the whole thing. Let's walk through that. Input is the one that we inputted, right? And then output is okay. So here output is output contains, if you remember, all the previous messages. So output contains, it's starting with the human input we provided, and then AI saying that call the tool call get tracks by artist, and then the tool actually called. It's the same we saw in the notebook, but it's a real output coming from the LLM, and then tool is going to give this information. These are the information provided by the tool, and then when you go scroll down, and then A is saying, yeah, I mean actually at this point A call the LLM and then give the response back to you. So these are all the sequence, but we can go a little bit deeper in that. If you go here, again, apparently it maintains the steps. The standard steps maintained is 24. Then O3 you know, this is, we are calling that, LLM to say, hey, this is a prompt that you don't see it. This is a prompt that you see it, and then we are passing this LLM to tool. We are providing the tools to LLM, saying that these are the tools, and then this is a question to the LLM, and then LLM will answer this. So this is important information. Suppose if you don't see the tools that you think need to be there, that means something wrong in your code. In your code, the music tools node is not initializing the tools properly. Apparently, in this case, we are passing the tools properly to the LLM so that LLM can make the judgment. Then should continue. Should continue node. Should continue is a function, right? I mean, that is also traced in the LangSmith. Instead of LangSmith, I would say that the LangGraph, the agent is automatically output or trace the should continue function. Then in the should continue function, you can see that continue is coming, right? The continue is coming means what? I got the artist data, but I'm still not done, because the question could be that we need to format it, right? And then it's going to call the music tool node, and then next is get tracks by artist. That is part of that. Again, I went through this in the top one, just a little bit details in a separate steps, but the overall steps I went in the top item here. What important point is, at the end it's going to say end, right? At some point, you are telling the LLM, hey, here is a data, here is a tool output, here is a question, and do I have anything to do? Then you would see that end will be met here. End means, if you go to the end output, I think so. This is this is the output given to the should continue, and then should continue function will say end. Yeah, the output from the should continue will be the end. So at this point, the flow or the loop ends, and then React pattern, I think would say successfully completed it. So I think you have to walk through this couple of times to understand how the tracing happens during the React workflow. So this gives the visibility. The point I'm trying to make is that this gives a visibility for all of us to get to more information about how things are going. Let me pause here, and then I'll ask any questions from the team.
Can I ask a question?
Yes, please.
So in the lang chain, we have the prompt, right? So is there a for the prompt optimization, there is something called DSPY.
Yeah.
Do you have any thoughts on that? I know for the simple cases, but the production grade, enterprise grade, how to scale the DSPY, that's where I'm not 100% sure. So
I mean, that's a very good question, Karkai. DSPY is coming from Stanford, right? And then library. So that is one of the auto way to optimize the prompt. That is definitely used in production. But still, it has not become a mainstream yet for some reason. But I do believe DSPY like technology where we don't need to write a prompt. It's basically you tell the DSPY, here is the expected answer, here is maybe initial prompt. It will automatically figure out the right prompt, right? That works for the situation.
Yeah.
And then they have so much libraries, right? And then extensions to keep updating the prompts for specific industries in verticals. Yes, I agree. I mean,
do you have examples or where it can for the creating the complex ones? Everywhere I saw it's a simple ones, but in the production, you have 5 or 10 different data sources, 5, 6 another APIs, and the combination of structured, unstructured, and the
no, you wanted okay. So I mean, the question is, yeah, DSPY we do first of all, right? I mean, even in the meetups we have taken DSPY example a few times. There are You can see the recordings. But the question is, in what I have not seen myself is LangGraph with the DSPY as an example. I have not seen myself.
Yeah.
In other words, when DSP was coming, it was meant for RAG. Obviously RAG was prime at the time, right? And there are many RAG implementations are using the DSPY. But when now that agents are taking over, so yeah, good question, right? How agents can use the DSPY, which is DSPY is also a library, right?
Yeah.
And that means you need to run a few times so it optimize the prompt, and then it gets ready for the production. So
Yeah.
it's like during development, you need to do that.
Yes.
Yeah, the combination of DSPY prompting and then prompt management. And now we have to see how to fit into the LangGraph as example is a good question. So I'm hoping that we'll have some examples soon on that. But to
Oh,
answer your question, we do have RAG-based DSPY example, not agents at this point.
okay. Another question I have is like LangFuse versus LangSmith.
Yeah.
So like with the LangChain, LangGraph, how difficult or easy to use the LangFuse?
LangFuse?
Yeah.
I don't know that question. Yeah. So if anyone, yeah, I so LangFuse is I think previous before LangSmith, right? LangFuse was there. Uh,
Okay.
right now, the way I see it in my company, other places, there are three components. One is the, as you see, LangGraph SDK, right? Other one is a
Mm.
LangGraph platform, right? That is where you deploy all the LangGraph agents, and then LangSmith. Yeah, yeah, these are the three things I see, but LangFuse, I'm not sure.
Okay.
Yeah. Anyone has answered for that? LangFuse, how they fit into this in the LangGraph right now? Okay. So I'm looking at thank you. The orchestrator is not the other agent. I think I'm thinking. So orchestrator is the is yes. I'm going to show that right now. Orchestrator is which is a supervisor, if you mean, is a part of that agent flow. Okay, let's go into that. Okay, so I mean, I'm looking at the time, right? I mean, what I want to cover is I'm not going to cover everything. The evaluation is what I'm going to jump in. But before that, I'm going to quickly run through that, right? So now we are going to, build the React agent for the invoice. I'm sharing the screen again for the invoice sub agent. So one thing you may want to note down, there are it's the same concept, invoice, gets the tools and stuff like that. I'm going to just pass through it quickly, and then you have the invoice sub agent prompt. You need to write it, and then so one thing for the folks who are new to these tools, right? When you're writing this prompt, right, you need to specify what tools to be used. But if you're using MCP as a client or MCP as a mechanism for tools, even you can avoid these things. You can say that, look into this MCP server for the tools, and then based on the availability, tools availability, find out the best tool. You can say something like that. So, so that means with the MCP coming in, even this prompt becomes much easier. So you don't need to know about the name of those tools. So all you need to quantify, I mean, write the proper responsibilities. So this becomes even simpler in the MCP world. Okay, now what I'm saying here is, there are other thing to know. The last time when we created the music catalog agent, we need to create the start and end, attach the conditional node, should continue. We had like at least 7-8 lines of code, but that is even minimized now. What they call pre-built libraries by the LangGraph. In this case, React agent, all it has a one-line information. So you have these three tools. Again, this even will be minimized if you have the MCP reference here, and then name of the agent, and then the prompt, right? That's all. And then in memory store checkpoint. So this automatically builds the React agent between the prompt and then tools. So it's a one line statement. So imagine an agent builder can create this statement pretty nicely, right, for your conditions. So this becomes the core piece of the code for the minimal code, one line code to create the agent. So tools being the important part, right? I mean, other than that, creating agents is pretty straightforward. All right, we are done with the agent creation, and then we are creating this testing. It's going to test it. Now, while it's testing it, let's move on to the, yeah, it probably completed the testing. So, here the question we asked is customer ID is one, what was my most recent invoice, right? And who was the employee that helped me with it? Apparently, in a little complex. In this, you see that compared to the previous one, you could see that it calls the tool 2 times, a little more complex, and then ends. The first time it's calling the invoice agent, and then sorry, first time it figures out get invoice by customer ID is the tool to be called, and then the answer comes from the tool, right? This is the information the tool provides, and then uh, we need to understand who is the employee that helped with that. See, the LLM on its own, right, and the reasoning node is going to find out a call, basically tells in the right now what is missing here is it's called the LLM, and then LLMs comes back and say invoice information a sub agent need to be called. Sorry, and then the tool to be called is get employee by invoice and customer. Then it says that invoice ID 382 for the customer one, and then it continues from there. And then you can go scroll down more. Let me scroll down here. Yeah. And then the most recent invoice is the 382. And then the employee who associated with this invoice is somebody called Jane. So that's all coming from the tool called get employee by invoice and customer. So it's providing that information. Jane is the one who helped the invoice. So this time you see that 2 times the tool is called, and then the loop ends. That is a, and when you look at the Langsmith, you might see that coming here. Yeah, invoice information sub agent. So here you see so many traces are there, right? So take we need to keep going and then understand each of these. So okay, so far this is good. I'm going to the multi-agent architecture. So I'm going to skip it. Multi-agent architecture is also very simple. It is nothing but the query routing type of a thing. In other words, a supervisor decides, right? Again, it says that if you have questions going for the music, go to the music agent. If the question is relevant to invoice, go to the relevant invoice agent. So you mentioned that in the prompt, and then create something called supervisor node. It's a special node. See, these are the things LangGraph provides. LangGraph provides a pre-built supervisor node, a pre-built React agent, and then pre-built so many other agents. What are the other pre-built agents? You can go to the website. So I can show you a little bit later. Yeah, I'll show you that later. You can go to the LangGraph website and then see what are the other pre-built agents. You can see that. Okay, so now I'm going to talk you to the important, another one. So what I'm going to do at this point, so assuming that the supervisor is run, but I'm going to take you to the other concept. The concept here is very important. So I'm going to, all right, if you can see my window. So now we are switching, our concept into, okay, so now at this point, you are familiar with creating a simple agent. And then we created music catalog agent, and then invoice agent, and then we created a supervisor agent, and then we put together in the graph. And what I not shown you is adding the human input. You can go through that on your own. But right now, evaluation. So now, how do we evaluate this, right? Again, my point is, during the development, you saw that, right? The prompt writing, we cannot write complete prompt from the beginning correctly. So something needs to be iteratively developed. So if someone is developing this, they'll be jumping on this evaluation first. And then there are three types of evaluation you can think. One, of course, this is crucial, right? When we know things are very flaky in the LLM world. If prompts are changed a little bit, the workflow might change, right? Or if you use a different model, today ChatGPT 5 came, a lot of people are complaining that OpenAI removed that previous model and then something is breaking, right? So whenever new model comes, you need to be careful. And then new architecture, your React architecture changes a little bit here and there. So every time something changes on these factors, your code, your response, and your application agents will behave differently. So what more and more important is that what we call evaluators, right? That is the key aspect of testing your application. So there are two types of evaluator. One is called offline evaluation and then online evaluation, right? So what is that? Offline means, right, while you are developing the coding, you want to incrementally ensure, you are incrementally improving. That is offline evaluation. That means you know what you're testing. You probably know, I'm going to test this agent for this input, and then this is expected output. So it's like our test cases. So yes, it is easy to visualize. It's a kind of test cases. So you know the input and the expected output. Then you want to measure. See, unlike in test cases, in traditional development, you can look at the output. It's a quantifiable, verifiable. You can have some metrics easily. Sometimes in the agentic world, the output could be not quantifiable. Yes, sometimes it's quantifiable. Sometimes you need to judge the output. So going back to the reg world, you probably heard about the LLM as a judge, right? We get the output. Output will have some string, and then the expected output will you predefined string you may have, textual string. Then you ask LLM to see, these things matches. So we might use the same LLM as a judge here, to evaluate expected output versus the actual output. But one difference here is the following. Unlike in RAG world, it's a simple text to text comparison. Here in agentic world, we also want to know whether we have taken the right steps. So that is new here. For answering one question, we went from there are two dynamic aspect, right? One is agent communicating agent. Okay, in our example, we are not gone to the agent to agent communication. In our example, supervisor. So how the supervisor is deciding which agent to call, and within the agent, how many times, what types of tools being called until the react loop ends. So there are so much dynamicity here, right? Sometimes for your question, one agent will be called, maybe two tools will be called. In other times, maybe three tools will be called. In other times, one and three tools will be called. So many permutation combination. So this is something. How do we handle that, right? That is the important point behind agentic coding, right? Agentic testing. So what these guys are provided, these means LangGraph guys are provided. They have created excellent evaluators, or libraries, you can say, which is going to give you the flexibility to test that easily. So that is something, I'm sure other agentic, that is something agentic platform has to provide, in my opinion. Not only way to run the execution, also visibility, right? That's one aspect. The third aspect is evaluators. They need to provide to make our life easier. So we are going to go through that. Online evaluation means something you want to test it during the real runtime. It is like testing your production code. So that is complicated in the agentic world also, because at least in the development time, how agents are supposed to work, supposed to communicate. But during the offline, you cannot test 100% cases, right? We only test a subset or representative type of cases. It's always the online or real production has much more complex scenarios. So how do we monitor and then actually come up with the metrics in online is a much more difficult problem. Okay, so but let's have first control over the offline evaluation first. So what we are going to do to make it simple, make it easy, I'm going to go to the code directly. So what are we now? I'm going to skip this part 3. You can run on your own. Basically, in part 3, you're going to add a human. We just finished this agent, and then we are going to create a verify info and then human input. So, as you type, the idea is, when you type something, my customer ID is 1, the verify info is going to verify whether the one customer ID 1 is present or not. So I'm going to skip it. You can read through that. And then there is a concept called interrupt. That means this is another important concept you can go through on your own. When any of the node during its running time, it can decide that I don't have much information. I want to interrupt my human and get the answer. So that's a very beautiful aspect of LangGraph. Imagine you have, in our case, only 3 nodes, right? But real workflow will contain 10, 20, 30 nodes. So you are somewhere in the node, it needs some information. So the graph engine needs to go back to user and get the additional information and come back and then start from where it left. So this has to be facilitated by the agent runtime platform. So LangGraph does that. This is something important part of the agent library. So it goes to the they call streaming. It goes to the any node can stream its messages to any reason for visibility reason and also for human feedback reason. So it goes to the human feedback, human enters something and comes back to the same execution node. So that is very important concept in LangGraph. You experiment and then you need to feel that it works. But right now I'm skipping through that. Here it is done. The reason I'm skipping is, I just want to go to the evaluation to finish the session. And then long-term memory is a concept. You load profiles and then take it from the profile and load it into the state. That's and then part of that long-term memory is what they're doing in this notebook. At the end of every session, end of agent completes a session, they are summarizing the discussions happen between the users and the AI, and then they're putting into the long-term memory. So I'm just going to skip that now. Okay. Now I'm going to go to the evaluation, right? Straight away, right? Here is the part. So the key thing I'm trying to convey today, we're all familiar with the RAG evaluation, so that is good. So okay, we start with that. There are 3 types of evaluators we are talking here. One is called let me go back to the. So now we're going to introduce in the next 5 minutes, all right, 34 now, is about 3 types of evaluators. One is the what we call evaluate the agent's final response. This is very similar to the our RAG world. Validate the final response. That is okay, fine. And then next is whether next type of evaluator, again LangGraph developed that, is whether it is taking the steps properly, whether when you for your questions does it basically understand then decides the best agent to the supervisor agent is able to find out the best agent, or it could be any other steps as well, right? And then that is called single important steps. Okay, and then third one is very important, is called trajectory. So what this says is that when you are actually testing, is your agentic framework or your agentic application is able to how do I know it's actually taking the right steps in the workflow. That's where I was saying, in the React agent, it goes in a continuous loop. But how do we actually visualize and then realize while we are developing, right? We are developing incrementally, adding the changing the prompts and then coming back. And then while we do that, we also need to not to break the previous workflow. We need to know, we need to codify, I would say that, the workflow trajectory test as well. So how do we do that? So here is what the proposal they do. Before do that, they are basically saying that, hey, the workflow will have multiple scenarios. We might need to handle multiple scenario testing. In one case, the expected trajectory, or the expected trajectory means what I think has to be the steps. Right now, I'm not giving the example, but imagine there are four steps the agent has to go through. One is get calendar at time 5, another one is calendar time 6, calendar time 7, and then something like schedule the meeting at 7. That is the expected trajectory, but the actual trajectory was like this in the flow. Then that is something wrong. The agency is not working properly. So that is one of the scenarios. But you may come back and say, in my use case, the order doesn't matter. As long as tool 1, 2, 3, 4 called in any order, I'm okay. I think my application is fine. If you believe that, then you can say that to the evaluator, my expected trajectory can be unordered, right? So once you say that, the evaluator that LangGraph team developed, what they do, if you think about, they go back and look at all the trace the messages, right? And then they parse the messages and they come up with this trajectory. So, but you have the option to say, I want to test for a ordered trajectory or unordered trajectory. Or you can even say that I am only looking for, in my use case, I know as long as the some subtough tools is called, I believe my use case is working properly. You can conclude that. So you can also say to the evaluator, this is my expected trajectory. So there are ways to specify that to the evaluator. So this is how you need to code. But let's go back to the code and say how they coded it. So this is the first one is in a simple testing scenario. This is more like testing the response. It's like any other RAG testing, right? You're saying my question is this, and then expected invoice ID is this, right? And then I would like to refund, and then expected response is I need additional information because you don't have any other context here. Could you provide a customer ID? So, and these are the sample questions and answer. And then what you do is there are three concepts, right, in the line graph. One, you need to specify the evaluator, and then you initialize the call the evaluator with the data set to be tested. So finally it is going to be look like this. I'll take it to the final call, uh, right, and then okay. So this is going to be the simple call. Basically what you do is client.create examples, and when and you give the input and then expected responses. This 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 is what we call testing using the for the simple response. I'm going to take you to the complex one, but this is an example of creating the data set and creating the evaluator. Now there are other things. If you go to the evaluator, so first is create the data set. Second is I'll come to this application logic to be evaluated, but the last one is the evaluator. So here we are using something called create LLM as a judge evaluator. Remember I was telling, for simplest scenario, the way to compare the input expected output with the actual output, use LLM as a judge. It could be the same LLM or could be a different LLM. And then in this case, LangGraph provided this library called LLM as a judge library. And then you pass something called correctness. You're looking for the correctness in the responses. When you do this, the LangGraph library is able to compare and then contrast and then give the results. So let's try this here. Okay, so I'll take it to the results as it is doing. I mean, it finishes all the 5, then yeah, I mean, it's still doing it. As you saw, it is still LLM as a judge testing, but it's basically going to say for all the 5 test cases, the expected output, and then output, yeah, it is coming. For one of the case, it seems failed. We will come back to the reason for the failure. And but just illustrate that it is just working now. It's simple response. Let's go to the next one. Next one is more interesting. Okay. Single step. In a single step is imagine which, basically you're going to call single step evaluator, but here what we are saying is for my input question, which route, which agent is actually being called. That is a single step. So you can say, what songs do you have by U2? Obviously, this has to be done by the executed by the music agent. So the expected answer is expected route. You can call it as a trajectory route or agent route. Expected agent to be called is this one. So you define this during your testing, and then again, same way you define the application logic, same way you define the evaluator. Here the evaluator is something, run supervised routing, and then run the evaluation. And then what is happening here is the LangGraph evaluator is going to be running this code, graph execute code, and then look at the output messages, and finally able to parse and figure out how this has happened. So now if you go to the single step evaluator results, you would see that, for this question, my name is Dada, output is this, expected output is this, and the actual output route happened is through this, right? This is a again, it's all happening by parsing the expected, the whole tracing. It works out of the Langsmith tracing, and then this platform is able to trace the Langsmith output, and then able to pick and choose, where to focus, for that evaluation criteria. So right now you tested the single step, right? And then the most interesting part is the next one. The next one is the workflow test. As you go here, here I'm just going to quickly go. So what you're seeing here is, again, for the same question, as a developer, right? For this question, first one, my customer ID is one. What's my most recent purchase? What albums does the catalog have by U2? So what's expected from the developers is the trajectory. It needs to go to the invoice agent first, and then call these tools, right? I mean, tools like get invoice and stuff like that. So this is the expected trajectory. Here you can give, whatever the trajectory you think, agent and the tools to be called. Remember, there are three ways: exact match, or or unordered match, as well as a subset match. The way you can specify that here, so the evaluators able to understand your criteria, and then able to compare and contrast. Now you're basically, running this. So I just went, what we are doing right now is running through the workflow evaluators, and then it's trying to complete that. Yeah, seems like I'm not sure why it failed, but some of the workflow is, I think one of the workflow expected or real output is empty, so it failed. I mean, we don't know why at this point, but maybe still executing it. Let's see that. Okay, so one of them is failed, one of them is null at this point. So there is something I need to go and check, but you can run it and then see the results on your own. So, and then the multi-turn evaluators. This is also another type of evaluators they provide, um, because many agents can be called, right? The nodes can be executed multiple times. One agent, not only within the agent, among the agent, within the agent also, the nodes will be called multiple times. So in order to test that, there is a multi-turn evaluator as well. So I'm going to pause here and then ask any questions. So yeah, someone answered that LangFuse is a powerful engineering and monitoring toolkit that helps teams production grade LLM. Okay, I see. Someone answered, what is the LLM Fuse? Thank you for that. And the another question I see. All right. So that is again about the LangFuse. And another question: could all of this done via ATA protocol from Google? Well, that's a good question. A2A, yes, ATA is a little bit handles the at a higher level. Imagine, imagine if we have LangGraph agents want to communicate to Crew A agent through the IPC, through the HTTP, through the internet. then the A2A agents obviously make sense. So I would say the answer is yes, but it is at a different level. A2A, and then things like Internet of Agents. These are all coming at a different level. Agent to agent communication, not within the same process. It could be hosted anywhere across the different organization, and then they can connect and talk. So that is definitely a next topic or different topic. All right, that's all the question I have. So apparently, okay. So no more questions, right? I will wait for a few more times. I can you can off the recording